Sound localization. An important aspect of hearing is our ability to localize sounds. Some animals can tilt or rotate their ears as an aid to sound localization. Although human beings don't have the ability to rotate their ears, we can still locate the source of a sound to a remarkable degree. Several factors aid us in this ability. One such factor is that sounds coming from in front of us are perceived as more intense than sounds coming from behind us. This is because of the shape of the outer ear. Cupping a hand behind an ear demonstrates how the outer ear makes sounds louder and easier to hear. Another factor in sound localization is the contour of the inner surface of the ear shell. As sound waves bounce off the ridges and folds of the outer ear, they provide localization cues to the brain. Using a dummy head with artificial ears, researchers have demonstrated that as they gradually smooth out the surface of the ear, sounds are much more difficult to localize. Localization is also greatly aided by timing cues, caused by differences in the arrival times of sounds to the two ears. Sounds coming from the right side strike your right ear first, then have to travel around your head, arriving at the left ear a microsecond later. Closely related to timing cues are the small differences in intensity and phase as a sound strikes the two ears. As the acoustical information is carried from the inner ear to the brain, there are processing centers along the way that analyze these cues to provide awareness of the location of a sound. Of particular importance is the olivary complex. The medial olivary complex analyzes temporal discrepancies and helps to locate the source of low tones. The lateral olivary complex specializes in detecting intensity differences and provides localization of higher frequencies. One role of the olivary complex is to create a spatial map of the origins of the sounds we hear.